On this channel, we provide useful programming information with practical code examples. This time, we will discuss functions in TypeScript. You can learn about various ways to define functions, such as function expressions and arrow functions, as well as function overloading. Enabling subtitles will make the code descriptions easier to understand. Functions in TypeScript are JavaScript functions with added type annotations. In TypeScript, you can write more robust code by clearly defining the types of inputs, parameters, and outputs, return values, for functions. Below, we introduce the basic methods for defining functions and some characteristics of functions in TypeScript. The add function takes two arguments of type number and returns a value of type number. It takes two arguments, x and y, both of type number, with their types explicitly specified. The return type is also specified as number. Anonymous functions and function expressions can also be used in TypeScript. Types can be annotated in the same way. You can assign an anonymous function to a variable and call it later. You can use a named function expression to enable recursive calls. Type annotations can be used with arrow functions as well. This code defines an arrow function, subtract, with type annotations that takes two numbers as arguments and returns their difference. Parameters can be made optional or given default values. Adding question mark after the parameter name makes it optional. This code accepts an optional argument. If the argument is provided, it greets using the name, otherwise it returns a generic greeting. You can also set default values for parameters. This function uses guessed as the default value if no argument is passed, and greets using the specified or default name. It is also possible to define the type of the function itself. For example, this is used when passing a function as an argument. This code defines a function type, operation, that takes two numbers and returns a number, then uses it to create and run addition and multiplication functions. For functions with no return value, specify the void type. This code defines a void function log message that takes a string message and prints it to the console without returning a value. Passing a function as an argument to another function and having it executed later is called a callback function. It is frequently used in asynchronous processing and event handling. In this example, a function that outputs a value to the console is passed as a callback function. Alternatively, you can define a callback type using type or interface. Defining a callback type using type or interface improves reusability. Function overloading allows you to define functions with the same name but different parameter lists. In TypeScript, you can define multiple functions with the same name and perform different operations based on the types and numbers of parameters. In TypeScript, overloading is achieved as follows. Overload signature defines how the function can be used, its signature. By writing this multiple times, overloading becomes possible. Implementation signature implements the actual function body. This part is defined only once and handles all cases declared in the overload signatures. The following rules apply to function overloading. Order of overload signature definitions. Since evaluation occurs from top to bottom, it is recommended to define specific types first, followed by more generic types. Compatibility of the implementation signature. The implementation signature must be compatible with the arguments and return values of all overload signatures. Specify details in overload signatures. The implementation signature tends to be ambiguous, so details should be specified in the overload signatures. If only the implementation signature is defined, the type inference for the function will be insufficient. Functions in TypeScript have the following characteristics. Type annotations. By specifying types for arguments and return values, you can write safer code. Anonymous functions and arrow functions. They can be used just like in JavaScript, and adding type annotations improves type safety. Optional and default parameters. You can make argument specification more flexible as needed. Function type definitions. Define the type of the function itself to perform type checking. Function overloading. You can support different arguments with the same function name. By utilizing these, you can write clearer and more robust code in TypeScript. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. Subscribe to the channel and check out our new videos.